So today we're going to be looking at lesson 6 of unit 3, which is isosceles and equilateral triangles. Now, as a recap from middle school, an isosceles triangle is a triangle with two congruent sides, meaning two sides are the same length. So when I mark that on our diagram, I want to say those two sides are congruent. We should have those tick marks to show congruency for side lengths. But there are various parts of an isosceles triangle. For example, we have legs. Legs are the two congruent sides. So the two sides that we put the tick mark. The base, be careful with the base. The base is not the bottom of the triangle, but the base is the third side. Because sometimes our triangle will not be oriented the same way that our diagram is now. So the base might not be on the bottom. It might be on one of the sides. Next is base angles. Angles opposite the legs. So the angle opposite of our two sides that are congruent are our base angles. So the two angles on the bottom in this picture are our base angles. And then the third angle is actually called our vertex angle. It's the side opposite the base. It's also the angle between our two congruent sides. Now there is something special that happens when we have two sides that are congruent in a triangle. And this actually happens later on in equilateral triangles as well. It's called the Base Angle Theorem. Base Angle Theorem states, if two sides of a triangle are congruent, then the angles opposite them are congruent. Now, no, it didn't say isosceles triangles. It's just saying that if we have two or more sides that are congruent, the angles opposite them are congruent. So, for example, if segment AB is congruent to segment CB, so AB is congruent to CB, then angle A is congruent to angle C. So the angles across from them have to be congruent. And this works in converse as well. If angle A is congruent to angle C, then segment AB is congruent to segment CB. So let's look at some examples. Example 1, find the value of x. Well, looking at this problem, I see two congruent sides, so I know the angles across from these two congruent sides have to be congruent. So an equation that we can write would be 9x equals 72. Solve, divide both sides by 9. X equals 8. In B, we actually have the converse of the base angle theorem. We have two congruent angles, so I know the sides across from them have to be congruent. So in this problem, we actually have excess of information. That 17 we do not care about. It is extra. We might do that to you. So we can write an equation of 5x plus 5 equals 35. I'll subtract 5 from both sides. So 5x equals 30. And divide both sides by 5. X equals 6. Let's look at example 2. Example 2 is a little bit more challenging. It says find the value of x and y. So we have two variables we have to find. Looking at A, I see two sides that are congruent. So I know the angles across from them have to be congruent. But now we have a dilemma. In this problem, the equation that we could write says x equals 9y. Well, we have two equations in it, and that's our two variables in that equation. That's not really going to help us. So we're going to do an intermediary step. We're going to find out what these angle measurements should be. Because remember, both of those two angles have to be congruent, so let's just call them C for now. Well, I know the value of the angle that has x is C. I know the value of the angle that has 9y is C. Well, remember, all angles of a triangle add to equal 180 degrees. So let's use that. We know C plus 90, that box, equals 180. So let's combine like terms. 2C plus 90 equals 180. Subtract 90 from both sides. 2C equals 90. And divide both sides by 2. C equals 45. So what that means is both of these angles have to be 45 degrees. Well, now there's a different equation that we can write. I know this angle up top with the x has to equal 45, so I know x equals 45. Oh, well, x is by itself, we're done. Then the other one with the y has to equal 45 as well. So 9y equals 45. Divide both sides by 9. Y equals 5. So sometimes, unfortunately, we can't automatically set them equal. We have to do an intermediary step. So it's going to be the same thing in B. The two angles that are congruent are across from each other. One has an x, one has a y. So let's do our intermediary step. I'll call both angles C again. And you can call them anything you want. I'm just going to call them C. So then I know 98 plus C equals 180. Combine like terms. I get 2C. Subtract 98 from both sides. And we end up getting 82. Divide both sides by 2. And we get 41. So I know both of these angles have to be 41 degrees. So take a moment, pause the video, try to find out what x is and what y is. So we're going to find x first. It does not matter which one you do first. We'll write 5x plus 6 equals 41. Subtract 6 from both sides. So 5x equals 35. Divide both sides by 5. X equals 7. For the y minus 9 equals 41. Add 9 on both sides. Y equals 50. Example 3. Once again, find the value of x and y. Well, this is another problem with two variables. Let's see if we have to do that intermediary step again. So I know the angles across from our two congruent sides are congruent, meaning 3x plus 8 equals 53. Well, I only said one variable, so let's find x. 3x plus 8 equals 53. Let's solve. 3x, we're going to subtract 8 from both sides. To get 3x equals to 45. Divide by 3. X equals 15. Now to find y. Well, there are two ways we can do that. One, plug 15 back into that equation. So do 3 times 15 plus 8 to find out that angle measure. Or we can also remember that entire angle has to be congruent with the other base angle. So in other words, this other angle also has to be 53 degrees. So all angles of a triangle add up to equal 180. So I can say 53 plus 53 plus 8y plus 10 equals 180. Combine like terms, so that would be the 53, and the 10 to get 116. Subtract 116 from both sides. $8y equals 64. Divide both sides by 8. Y equals 8. Let's look at example 4. Example 4 is a proof. So we're going to want our two columns. Remember, our first column is our statements. Second column is our reasons. So it does say in this proof, prove the base angle theorem, meaning we cannot use the base angle theorem in its own proof. So we're going to have to apply different vocab words. So, first given, there are two of them. So we can say segment KB bisects AC given. So, what does that mean? Well, we had a vocab word, so let's deal with that vocab word, bisect. Remember, bisect means to split in half. So it literally says segment KB splits AC in half. Well, the two halves of AC are AB and CD. So AB is congruent to CD. And that is, once again, the definition of congruent, of bisect. Mr. Johnson apologizes. I'm going to put in my marks on my diagram. It's easier to see triangle congruencies from the diagram than it is just from words. Well, there's nothing else that we can do with that given. We got a congruency statement, so let's write our second given, which says segment AK is congruent to segment CK. So we said a congruency statement, so let's mark it. So I'm going to do the 2 tick marks. Okay, so unfortunately we do not have any other givens. And there's no other vocab words. So let's look and see what we can do with this triangle. I ended up having 3 different triangle look-fors. The first question was, does it look like a bow tie? If it looks like a bow tie, we have vertical angles. Well, unfortunately, this problem does not look like a bow tie. Second question was, do they share a side? If they do, we have reflexive property of congruence. And third is stating if they were parallel. Well, we didn't say parallel, but they do share a side. So I will write that side that they share. So KB. So KB, congruent to itself, KB. And that is a reflexive property of congruence. So I'll put 3 marks on. Well, we have 3 triangle congruency statements, which is what we need for any triangle congruency. So then I can say triangle ABK is congruent to triangle CBK. And our reason for this one is side, side, side. I want to do a quick check. Does our last statement match up with what our proof statement says? It does not. We want angle A is congruent to angle C. Well, since we said the triangles are congruent, we know everything about them has to be congruent. So I can say angle A is congruent to angle C because of CP-CTC, or corresponding parts of congruent triangles are congruent. So all that was about isosceles triangles so far. Well, let's talk about what an equilateral triangle is. The name equilateral is actually made of 2 words. Equa, which is short for equal, and lateral, which means sides. So equilateral literally means all sides are congruent. Knowing that then, equiangular triangles, equa, equal, angular, well, angle, all angles are congruent. Now here's the thing. Every single equilateral triangle is equiangular. And every single equiangular triangle is equilateral. Because remember of that base angle theorem said angles across from congruent sides are congruent. Well, if all the sides are congruent, the angles across from them have to be congruent. So for example 5, it says find the measures of angle P, angle Q, and angle R. Well, here is a math problem where we give you literally no numbers. The only thing that we know about it are the sides are congruent. Well, since all of the sides are congruent, all of the angles have to be congruent. So if I call angle P x, I also have to call angle R x and angle Q x. And we know all 3 of those angles have to add up to equal 180 degrees. So x plus x plus x equals 180. Or we can combine like terms and get 3x equals 180. Divide by 3. And x gets you 60. So then the measure of angle P equals 60. Measure of angle R equals 60, and the measure of angle Q equals 60. So for the last example, let's combine everything that we've learned. We're going to find both x and y. Well, just looking at the diagram, I notice that we have an equiangular triangle or an equilateral triangle, and we have an isosceles triangle. Well, on the isosceles triangle, the one that I highlighted in green, we only have one value. And by value, we have the x plus 1. However, for the equilateral or the equiangular triangle, there are two sides. Well, remember, equilateral and equiangular are the same thing. So if KL is 4, that's one side length, all of the other side lengths have to be 4. So NL has to be 4. And KN has to be 4. So just by looking at that then, y has to equal 4. The second thing, for isosceles triangles, sides across from congruent angles are congruent. That was our converse statement. So we know NL is 4, ML is x plus 1, and they have to be congruent. So we can write x plus 1 equals 4. Subtract 1 from both sides, x equals 3.